Hi guys, today we are going to review writing equations of lines, okay? So there's three equations that you need to know that will help you write an equation for a line. The first one is slope-intercept form, y equals mx plus b. You know this, we've talked about this many times, okay? There's your slope, there's your y-intercept, okay? The second one, point-slope form. So this is used when you know a point on the line and you know the slope. Here's your slope. The point is the point x1, y1. So it's y minus y1 equals m times x minus x1. Now there's actually some books where they move this over here. I don't really like to do that because this way stays consistent. You always take the opposite of whatever the signs are for x and y. Okay, the third one is the slope formula. M equals y2 minus y1 over x2 minus x1. Okay, you should know all three of these formulas by now. But if you don't, this is your chance to make it up. Okay, so here we go. Write an equation of the lines shown in the graph. Okay, so this would be one. We know the y-intercept. We can easily calculate the slope. So I'm going to go ahead and use slope-intercept form for this one. Y equals mx plus b. Okay, so the slope I can calculate because I can see that from here I can rise 4 and run 3. So my slope is going to be 4/3. So y is 4/3 x, and I know my y-intercept, which is right there. It's -3, and I'm done with this thing. Okay, now I could have used point slope form on this. Okay, so let's take a look at that real quick. Y minus y1 equals m times x minus x1. Okay, so my slope, again, I would calculate that. That's going to be 4/3. Okay, so that's going to go right here. And then I have a point right here, 3, 1, so it's going to be x minus the x coordinate would be 3, and it's going to be over here, y minus the y coordinate, which would be 1. So this is the same equation as this one, except it's not in slope-intercept form, which most of the time your teacher wants you to go ahead and turn into slope-intercept form anyway. So that's why I would probably use this. But if I were to do that, y minus 1 would equal 4/3 x. If I multiply this times 3, it's going to cancel the 3, so I'm going to get -4. And then I'm going to add 1 to both sides. And I'm going to get y equals 4/3 x minus 3, which is exactly the same thing that I got there with a whole lot less work. Okay? So you can use either one. Okay, write an equation of a line with a slope of -1/2 and containing the point 1, 2. All right, without a graph, this is actually easier to use point slope form. So I'm going to go ahead and write that down. I always like to write down my formula because it tells me where everything goes. Okay, so there's my slope. It's going to go right here. Here's my x coordinate. It's going to go here. Here's my y coordinate. It's going to go here. So I'm going to get y minus 2 equals -1/2 times x minus 1. And then if I need to put it in slope-intercept form, I can distribute that -1/2 in here real easy. Okay, and then I can add 2 to both sides, and I get y equals -1/2 x. 2.5 would be 5/2. And there's my equation in slope-intercept form. Now, if it doesn't tell you what form to put it in, then this is perfectly fine to leave it like that. Okay? All right, write an equation of a line passing through the points 3, 7, and -2, 2. Okay, so on this one, I don't know the slope. I'm going to calculate the slope. So I'm going to get my slope formula. M equals y2 minus y1 over x2 minus x1. So if you like to label things, sometimes this is easier for people. There's x1, y1, and x2, y2. So now we would have m would equal y2, which is going to be 2, minus y1, which is 7, all over x2, negative 2, minus x1, which is 3. So I'm going to get negative 5 on the top. I'm going to get negative 5 on the bottom. That makes 1. So my slope is 1. Okay, I can now write an equation because I have a point and a slope. So I can choose either one of these points. I'm going to get the same answer. All right, I like this one better. Okay, so I'm going to go with y minus 7 equals 1 times x minus 3. Okay, now I don't really need the 1 there, so y minus 7 is just x minus 3. Add 7 to both sides, and I get y equals x plus 4. And there we go. Now, if I wasn't sure, I could test this thing. I can plug my x in here. If I plug in 3, 3 plus 4 is 7. Oh, that point works. If I put in negative 2, negative 2 plus 4 is 2. Oh, that one works. I'm good to go. Okay. You know, here's the other thing, too, is, I don't personally use point-slope form a lot because I can do pretty much everything with point-slope form or with slope-intercept form that I can do with point-slope form. So check this out. If I wanted to just use slope-intercept form, I've calculated the slope here, so I could use y equals mx plus b. Okay, and my slope would be 1, so that would go here. And I have an x and a y, so let's choose this one this time. My x would be negative 2. I don't know b, I got to figure that out. This is going to equal 2. So 2 equals negative 2 plus b. And of course I can add 2 to both sides, and I get b equals 4. And I write my equation, y equals 1x, which is just x, plus 4, and I'm done. Hey, I got the same thing. Look at that. Amazing. Okay, direct variation. We've done this before as well. The variables x and y vary directly if for a constant k equals y divided by x, or y equals kx. The number k is called the constant of variation. Here's the deal. Remember, direct variation is just a line and slope intercept form that has a y-intercept of 0. It always has a y-intercept of 0. Okay? So y equals mx. Okay? All right. Hailstones are formed when frozen raindrops are caught in updrafts and carried into high clouds containing supercooled water droplets. So what you tend to get is you get these really tall clouds, okay, that kind of go like this, and you get an updraft like this, okay? And so the water droplets, they freeze, and then they get caught in this updraft, and they get carried up into the cloud. And the longer they stay in the cloud, the bigger they get, okay? So the radius r in inches of a hailstone varies directly with the time t in seconds that the hailstone is in the high cloud. So after a hailstone, so here's what I get, is I get an equation. The radius is equal to some number k times the time t in seconds that it stayed in the cloud. Okay? So it says after a hailstone has been in a certain cloud for 10 seconds, the radius of the hailstone is 0.5 inches. Okay, so the radius, 0.5, equals k times 10 seconds. Now I can figure out what k is, because I can divide both sides by 10. K is going to be 0.05. Okay, so I can write my equation now. Y is going to equal 0.05 times t, or I was going to use x, but I guess it's r, equals 0.05 times t. Now, I can put any time I want in there. I can calculate how big the hailstone is going to be. Okay, so if I look here at these are actual hailstones from Texas. They have a radius of about 1.25 inches. Okay, so the question is, how long would they be in the cloud? Well, we could use this formula to figure that out, because my radius would be 0.25. That would equal 0.05 times t. So I would divide both sides by 0.05. And I would get, oops, I'm going to need my handy-dandy TI-84 plus C Silver Edition graphing calculator or a reasonable facsimile thereof. 1.25 divided by 0.05. 25 seconds. Okay, that's a long time to be hanging out in a very cold, very tall cloud. Okay, those will do damage. You do not want to be outside in this. Okay? All right. So I got a little assignment here for you. Enjoy that. I will see you guys later. Have a great day.